Hey guys, this video is over the dissociation of soluble and insoluble substances. I know that sounds kind of weird for something insoluble to dissociate, but it does just a little bit. Alright, so remember the solubility rules that we used for precipitation reactions? Well, this is the reason that those precipitation reactions did what they did. So, if we have aluminum nitrate is 100% soluble. We can see that when we look right here at our solubility rules. Nitrates are always soluble no matter what. There's no exceptions to that because these are all soluble up here at the top. And so this is going to 100% dissociate. So we're going to draw it like that. It's going to dissociate into aluminum. And remember, aluminum has a +3 charge. We can just take this 3 out here outside of the parentheses and bring it up. And nitrate has a -1 charge. Now, one thing is we've got 3 nitrates. So there would be 3 of them. And if I have a 0.5 molar solution of aluminum nitrate, that means that I have 0.5 molar solution of aluminum. And I'm going to have 3 times that for nitrate, because for every single one of these aluminums that are made, we make 3 nitrates. So there's 3 times as much nitrate in the solution than there is aluminum. And all of this really goes away. We don't have any of that in solution because it completely dissolves. All right? Of course, unless it's past the saturation point, which we're not worried about right now. I just want you guys to be able to see if you have a certain substance and it's dissolving, this is what it's actually turning into when it's put into the liquid. To the solvent. Okay? All right, so if you have a hard time visualizing that, I'm going to draw a picture. We have aluminum with 3 nitrates, and this is not at all what it looks like. All right? This is 3+, and so there's 3 nitrates around it. And if this thing dissolves, then these bonds disappear. And so for every single aluminum that we have 3 nitrates. And so if we have 0.5 of this, then we would have 0.5, 0.5, 0.5. And so that's 1.5 altogether, and that's where we get that from. All right. So let's look down. I think I have another example down here. I have a 1.06 molar solution of magnesium chloride. And this is also soluble. So since it's soluble, it's going to all go over to here. And so we get magnesium 2+, right? And we get chloride. We get 2 of them. So if I have 1 magnesium chloride, I get 1 magnesium. They're 1 to 1. It's a mole-to-mole ratio. And so this one is going to be 1.06 molar, and this one is going to be 2.12 molar. So that's all I want you to do is recognize when you have these coefficients and what they mean and how those concentrations are affected. So if one of these things breaks down, we're going to have twice as much chloride as we have of the magnesium chloride and the same amount of magnesium. All right. So in this part, what we're basically doing is we're looking to see if it's soluble or not. On the slide before, they were all going to be soluble, so you could always find the concentration. On this one, you're not going to have to worry about concentration. So I just want you to be able to tell me if it's soluble or not. So sodium chloride, right here, here's chloride, and chlorides are soluble unless there was silver, lead, or mercury. Now, this is with sodium here, and so it's going to be soluble. Not only that, all alkali metals are always soluble. So this is going to dissolve 100%, and it's going to turn into sodium and chloride. And that's it. That's all I want you to do. So since it's soluble, we use this type of arrow. So that means that it's soluble. Okay. Now, silver chloride, chlorides are soluble. That's what this says up here, right? Chlorides are soluble unless there was silver, lead, or mercury, or silver, lead, or mercury. So this one is not. And that it always confused me that it would say that it was insoluble in the solubility rules. But then once you start getting into chemistry, you find out that that's not exactly true. In the text, it says that it's marginally to partially soluble. So what we use in chemistry was you use these arrows to represent that. And that arrow means, it means equilibrium. And equilibrium is basically a type of chemical reaction in which products are made and reactants are made at the same time. So once a reaction reaches equilibrium, the products are made at the same rate, the same speed that the reactants are made. And so you can't tell that a change is occurring anymore. And so what we get with this reaction, we get the same thing we would get if it was a complete reaction. The only difference, the only thing these arrows mean is this not all of the silver chloride turns into silver and chloride. See, up here with the sodium chloride, all of the NaCl turns into sodium ions and chloride ions. But with something that's insoluble, you get very, very little. So, for example, if I had 5 molar silver chloride, I might get 0.000001 molar silver ion, and the same for chloride. And every single insoluble substance dissolves to a different degree. And I know that's a lot of words, and it can be very confusing. You're not being asked right now to solve for that. I just wanted to show you what I meant when it says not all the silver chloride turns into silver ions and chloride ions. All right, I just want you to be able to tell me that an insoluble substance uses these arrows and not the straightforward arrow that we've been using all year long. All right, so for this next example, we've got lead 2 chloride, and so remember that's one of the chlorides up here that's insoluble, lead 2. So if I go back down here, this one is going to use the equilibrium arrows, and it's going to dissolve into lead 2 and 2 chlorides. So that's all you have to do. So one side of your worksheet has the concentrations on it, and they're all soluble substances. The back side of your worksheet has these mixed up, and you just have to use the right arrow and dissociate into the right number of ions.